All right, welcome everybody to the SEMA collision and refinish repair stage. We got it. My name is Joel Dufkis. I am EV and ADAS instructor with iCar, and I have Joshua Linton here from Midtronics. Joshua, tell us a little bit about yourself.
Sure. So at Midtronics, my focus is on EV safety solutions, and we have a number of new products which we're now introducing into the collision space. We're very excited about it, and always excited to partner with iCar. Yeah.
Well, thanks for being here. I know you guys got some cool tools that can kind of help out in the EV space because, you know, obviously we need to know what's going on with these cars when we're get them in to be repaired. So let's get going here.
Sure. So if you know Midtronics, which I know you do, but in the collision space, perhaps there's still some that don't. Midtronics has been around for 40 years, solving originally 12-volt battery warranty problems for OEMs, and we work with pretty much all of them. And now, as EVs are increasing in adoption, increasing in vehicles in operation, as they then get in accidents and need repair, so, making sure that the right tools to ensure that they're repaired safely and ensure the repairs are done with confidence are very important. And that's really the focus that we have here today. Yeah.
Cool.
Yeah.
So I know we're going to start talking about, we're getting some safety stuff here.
Yeah. So let's start maybe from your view, Joel. Just a little bit of set the baseline, a little bit of 101 about EVs in collision, EV safety, and a little bit of the 101 level about safe practices. Yeah.
Yeah, so obviously when we come up to the vehicle, we want to be cautious.
Yeah.
We want to make sure that we're following the OE procedures as far as what kind of PPE you need to have, the base level, high voltage gloves, safety glasses, but every OEM procedure varies different depending on what it is, so always check those procedures before you actually get into stuff. But actually just looking over the vehicle at first. When we get this car in from a collision, we want to go through and do some checks outside the shop. But don't bring it in the shop yet, because if something does happen, we want it to happen outside, not inside the shop where bad things can happen, you know? So going through, scanning the vehicle, looking for codes, looking for the cell balance data, the temperature data. Start using some tools like a CO detector to detect around, looking for off-gassing on the battery. A thermal imaging camera, looking for off-gassing that way. And after we see that stuff is good, then we can kind of move in the shop. But if we see it's not so good, then we can quarantine the vehicle and continue going from there. And that's where kind of some of your tools come into play here, where we can actually use these tools to help kind of check the vehicle out and make sure that it's a bit safer.
Exactly. And what would you say are some of the, or what is the level of confidence in collision space that technicians have today? And are they confident as an industry? Are they confident to repair and work with the EVs, or how would you describe that?
That's going to depend on training level. Obviously, we do a lot of EV training, and you know, we get people that come into classes, they're still a little leery of EVs, and they haven't had a lot of EV experience. So rightfully so, they're a little nervous about it. After they go through the class and they get the training, then they leave there with a really good confidence that they know what to do and how to approach these vehicles. But as a whole, you know, EVs are new to everybody. You know, it's not just like a collision repair space, it's an everybody space. Mm-hmm. So everyone just needs some sort of training and to get comfortable and confident on these vehicles that they can work on them safely and effectively.
Yeah, yeah, it makes sense. And it's a gap that will have to be bridged.
Yeah.
And we have to continue to work to bridge that gap. And you talked about a number of safety kind of 101 PPE elements. This is some examples of them. Anything to call out here specifically?
No, just depending on what your level is. You know, obviously a rescue or safety hook.
Yeah.
So in case something happens, someone can pull you off of that right away, help, you know, maybe save your life.
Yeah.
Eye protection, face protection is a paramount. You know, we only get 2 sets of eyes, so if something happens to them, you know, there's no bionic eyes yet, so, you know, you get our high voltage gloves. That's going to help protect us, insulate us from any sort of voltages. And, you know, insulated tools are there for in case we're doing repairs and there's going to be, you know, loosening up cables and stuff like that are associated with the system. It's good to have that type of stuff. So depending on what we're doing, we're going to need various levels of PPE, but you need to have the stuff on hand and know how to use it. Make sure we're testing our gloves before we use them. Make sure that we have an arc flash suit available in case we do get a car that's in a pretty decent collision and we are questioning what's going on with it. Suit up. Make sure you're following those procedures. Follow the OEM procedures. That's all I can really say. They're the ones that built the car. You need to follow what they're saying.
Sure, that makes sense. Really good points. I think that also managing the shop space while you're working on the car, is that correct?
Yeah, for sure. You can see we have the car kind of blocked off.
Yeah.
A lot of OEMs want the cars to be blocked off all in the shop. And that's in these shops, we're going to have gas cars, ICE cars, and EVs and hybrids and stuff. And how do we delineate between what car is what? Because obviously there's some safety hazards with the full EV. So by blocking those EVs off and putting signage on them so that everyone in the shop's aware of what's going on is going to make it just safer overall. Keeps the people out of the area that shouldn't be in that area. And it's just a good practice. And most OEMs want something like that done.
Sure.
And then, even then when we get to like quarantine a vehicle, if we have to quarantine it, most manufacturers are, put them outside 50 feet away from everything and making sure there's space in between the block offs and the vehicle itself.
Sure. Indeed, best practices. And I think that when technicians actually start working on the car, there can be a lot of questions that come up, all related to safety and ultimately repairing it correctly, right? And so one of them, an initial question is that depending on the type of collision and the damage caused, could the vehicle move unintentionally, right?
Yeah, that's definitely something we don't want to happen, especially for the first responders and second responders coming to the scene, in addition to, in a collision shop. But I really think with this, like, as you're the first person on the scene or the second person on the scene, I want to make sure the car's not moving or, nothing bad's going to happen.
Yeah, exactly. And to address this safety concern, Midtronics has developed the XIM 100, which is electric vehicle immobilizer, and we support NACS or the Tesla connector as well as the Type 1 connector as well, fully ruggedized, IP54, so it's basically waterproof, and we also include this removable magnetic pry bar in case the charge port door is challenging to open.
That's a good feature to have because you never know when you need that pry bar and just sits right on the tool. And like you said, you have the NACS port here, the J3400 standard. And we have the J1772 connector as well. So we have both connections that are found here in the United States with the J connector or the J1772 being phased out now, being replaced by the NACS connector.
Even by the non-Tesla OEMs, right?
Yep.
Yeah, exactly. And so this is a fully ruggedized tool for first responder use case to solve for that immobilization question. It glows, if we can show on the camera here, when it's plugged into the vehicle, if the vehicle is not immobilized, it glows bright red. Yeah, and then if it is immobilized, then it will show green, just the same, right?
Yeah, it's a pretty interesting product, and it does what it's meant to do. It's meant to disable that car so it can't move, because when these cars are plugged in, or they think they're plugged in, that immobilizes the system. The car can't move, so we're using that technology to make sure that the car can't move out of the way, and it's something, like I said, for that first and second responders to really make sure that car's not going to get going or move out of the way, especially after an accident, because you know how it is. It's a chaotic scene after an accident. Someone might forget to put the car in park or something like that, and this will help solve that issue.
Exactly, yes. That's exactly the case with that one. And so the next question, if we can go back to the slides, the next question is the vehicle conductive surfaces, are they electrified? Can we actually can we touch the vehicle, right? And this could be a huge safety risk if indeed it is. And so if you can grab the XVT, we have our surface voltage tester here, and if we can show that one. Basically, quite simple. It's a surface voltage tester. We have our measurement tip here in the front, and then we have our indicator LED bar here, and you can see that if you go ahead and this is flexible also, by the way, right? and so you can get into hard to reach places. But if you touch that conductive plate right here and press the button, you'll see that the conductive plate right now is not electrified, right? Quite simple, green.
Yeah, it's good because it's lighting up the LEDs on the tool by my finger, but also down at the tip too, so it's kind of showing you in two spots.
Yes, exactly. And then if we put voltage on that plate, then you see that it turns red and also vibrates and also beeps.
Yeah, it's beeping and it's vibrating my hand, so it's really telling me, hey, there's something here or this is not good.
Take caution, right? And that's just, I mean, you really see how simple it is to use.
It's you push and hold a button.
Yep.
That's all we're doing.
And so this kind of like before and during repair, just as part of the basic PPE kit, I think it's quite important to make sure that that vehicle is not electrified when you're working on it.
Yeah, if you have questions about that, if you're unsure about it, you can go ahead and just use this tool and go ahead and touch the surfaces and hit the button and basically tell you is there voltage there or not. What's the voltage threshold on this tool?
So right now it's the 40 volt threshold, right? Some OEMs vehicles are they have a potential for like a 35 to 38. So 40 volt is a standard, and it can be customized eventually.
Yeah, and based off of FMVSS 305, they state 60 volts, anything less than 60 volts DC is safe. So this tool's even bringing that down even closer.
We have
to
a
zero.
margin of safety as well.
Perfect,
Yeah.
perfect. That's a good tool to have in your toolbox.
Yeah, yeah, good one. And then if the next one is the next question is the AC charging system compromised? And for that, we have a multifunctional solution, which is our XHVS 3000 diagnostic solution. And with this, we're answering a number of questions, including is the AC, the function of the AC charging system, right? And so we plug into the electric vehicle with this plug portion, and we perform the immobilization test, which we talked about earlier. From a diagnostic point of view, is the charge port working correctly? Will the vehicle move when it should not move, as a safety check there? And then we proceed to the insulation test. And there we want to assess the installation and the safety of the onboard charger to determine the safety of that AC-DC rectifier.
And that's very important because if you think about it, the main area on an EV that there's high voltage cabling going to that's going to be interacted with in an accident is going to be the charge port. Some cars have them on the rear quarters, some have them on the front fender, some on the front bumper. They're all over the place, but they're all in easy spots to get hit in an accident. And in that accident, it could compromise the charge port itself or cause isolation faults and things like that, where this tool will actually go through and do the testing on that to verify to make sure that stuff's, that the charge port wiring is kind of there and intact, but also are there faults with that system? And not a lot of cars can identify that sometimes either. So this is a good way to test that and make sure that things are safe and that even after the repair, use this tool to verify that everything's working correctly. That you didn't have a bad charge port that you may have misdiagnosed or just didn't replace.
Yeah, and I have a question for you about using this type of a solution to do that test versus solutions that are currently in use in shops today, as far as, and also as it's related to, let's say, different levels of skills and training on the technician side.
Yeah, obviously compared to using an installation meter and getting it all set up and making sure you're pinning out the right pins on the charge port and doing all that stuff, there's a lot of room for error inside of that stuff. Where with a tool like this, that plugs right in and it's all controlled via the software, it's doing all the checks for you. It knows which pins to check, how to check it correctly. So you're really removing a lot of the human error out of that stuff, which helps make things a lot safer.
Mm-hmm. Yeah, ease of use is critical in order to to deliver the high quality, ultimately reliable data.
So what is the probe here going to do?
Yeah, so the next test and safety question about repairing the vehicle is related to ground bonding, right? And what is the integrity grounding integrity of the high voltage components as they're then grounded to the chassis. And that's exactly what we're using this probe to measure, right? Simply, remember, we're connected back at the charge port still, and that's where we have our connection to a protective earth or the chassis ground, right? And then we're measuring with the probe the grounding resistance value when we simply touch each high voltage component, right?
So we're doing a milliohm test
Milliohm
for bonding
test.
for equipotential bonding.
Yes.
So after we repair a vehicle, say we have to replace a high voltage component or something like that, which may or may not happen. When we remove that component, there's sometimes bonding straps that bond from the component to the chassis, or sometimes the components are just bonded directly to the chassis. And after we replace those components, or even remove them to fix something else, we put it back, we need to check to make sure that they're bonded back to chassis. So there's a low resistance pathway back to ground, so that in case there is an isolation fault on the vehicle and you touch the wrong things, you're safe. But if you don't check your bonding, there could potentially be an issue there, right?
Yeah, indeed. And we're providing, now there we're using the universal 100 milliohm threshold, right? And we're providing all those resistance values and all the values in a single report back to the user, right? So it's very easy. There's no note taking. It's a very seamless process, yeah. And then there's...
Does that get reported like to your a cloud service or something like that?
Yes, it's a connected tool, and it can also be integrated into shop IT infrastructure to provide, to ultimately deliver the complete report by the end of the repair, right? So it's really whatever way is to collect the data is best, we can support.
So I can use that as documentation later on, like what I did, and this is what it was before, and this was what it was after, so I have a clear understanding of what happened and how we fixed it.
Exactly, yeah. And then there's the fourth test, which XHVS is also supporting, which is the AC touch current test, right? And so in a scenario when the charging station may have a ground fault problem and the vehicle has the insulation fault, then you have the risk where the charging station shouldn't charge a vehicle, but it does, and the vehicle shouldn't accept the charge, but it does, and then in that scenario you can have AC current flowing on a conductive surface, and someone can touch it and get very injured or die, right? And so while it's a low probability because two things have to go wrong, the risk is very high, which is the reason we include it as a diagnostic here, right?
That's good. The more tests you have, the more that you can verify stuff, the better off you are. Like you said, it's going to take a lot of stuff to go wrong to get to that point.
Yes.
But there's always a possibility.
Sure. Exactly.
So this tool, the XHVS, combines some of the stuff from the
we combine
IM100, right?
Yeah, we have the immobilization function inside the XHVS as well. Basically, you can think about it from a development standpoint. We started with XHVS, and then we realized that the immobilization alone has great value for first responders, and so we.
But they don't need this whole giant.
But they don't need all the diagnostics, right? And so we developed as a standalone as well, right, with the full ruggedization. Yeah.
Nice.
Yeah. Yeah. That's how that evolved. Yeah. Good. Yeah, so we talked about AC touch current. We talked about ground bonding. Are the high voltage components grounded to the chassis?
So going back to the bonding stuff,
Yep.
so that you're going to use the probe here, and it's got this long cable on there, so you can plug this in the charge port, put the car up on a lift, or go under the hood, and start basically just touching the probe to different spots on the high voltage system to check that bonding resistance then?
Exactly, yes. And then you simply push the button on the probe each time you touch a different component, and you capture that measurement. It's just like a camera, right? Push the button, take the picture, and then move on.
Okay,
Yeah.
so you can create a whole list of all the different surfaces you tested for bonding.
Yes, exactly, yeah. And then the next question is, well, wait a second, we're talking about high voltage system, but what about the low voltage system, and can that 12-volt battery support the vehicle? And in the collision shop, there's a lot of focus on repair, many different aspects, mechanical, electrical, but is there a level in your opinion, the level of attention to the 12-volt battery and maintaining that battery in the collision environment?
Yeah, in any environment with these EVs, the 12-volt battery is very important, or in this case, called a low-voltage battery because it can be 12 to 16 volts depending on the OEM nowadays, even up to 48 volts now, depending. But the importance of that's what closes the contactors to turn the high-voltage battery on to turn the car on. If that 12-volt battery is not working, you're not going to be able to start the car, essentially. On top of that, I've seen a whole bunch of stuff where the low-voltage battery gets low, and it causes all sorts of havoc in the system where you get weird codes and stuff like that. Things aren't working correctly. It can lead you down a misdiagnostic path from that. So having a tool that we can test reliably the low voltage battery is important, but a lot of people think that I can just go and use a regular old battery tester on these things, but is that true?
You know, it's really important that we test the 12-volt battery or whatever low-voltage battery. We test the battery for its application, right? And I think typically many tools, and for good reason, many 12-volt tools today are intended for ICE because that's the main portion of the vehicle population, right? But the use case of the battery, its role in an ICE vehicle is fundamentally different versus an EV, right? There's no engine to crank. And so basically, the 12-volt has to provide all the power and support to all the low-voltage systems of the EV, and that includes all of the safety systems, and especially in the modern vehicles like brake-by-wire, steer-by-wire, emergency SOS, seatbelt sensors, and many, many more. The 12-volt battery has a huge job, and cranking is not one of them, right?
If we look at ICE vehicle batteries, how do we rate them? We rate them by CCA, cold cranking amps. My EV doesn't care about CCA because it's not using CCA. It's not cranking anything over. We're more worried about amp hour capacity and reserve capacity at that point, which we've never really measured for typically in a traditional battery test, right?
Sure, that's exactly right. And so Midtronics, with this new problem, and we love to solve new problems. With this new problem in mind, we have created a new 12-volt capacity diagnostic technology, right, called Safety Power Diagnostics. It's quite simple. Why do we call it Safety Power Diagnostics? Because it's the diagnostic for the 12-volt battery, which is powering the safety systems in the EV. And we are introducing this now, which is Safety Power Diagnostics, and it's the highest precision capacity diagnostic in the industry because we provide the actual value on the screen of the tool about how much capacity is remaining in the 12-volt battery despite potential degradation over its life through usage and weather and everything else. And so at a certain point, that battery cannot support the vehicle, and we show you exactly in that snapshot at the moment where it is in its life. So.
Yeah, it's also pretty cool too because this tool also checks the DC-DC converter too, right? Which is your alternator on a EV vehicle.
Yeah, exactly. You know, checking the battery is one thing. Making sure the vehicle supports the battery is another thing. And so we want to make sure that the vehicle is properly charging the 12-volt battery in addition to testing the battery, right?
Yeah. And one thing we see was when the vehicles are in an accident, depending on the level of severity of the accident, we can blow pyro fuses and things like that. And once those are blown, it stops supporting the low voltage system. So that whatever that low voltage battery has inside of it is going to be depleted at one point or another. And essentially at that point, you're deep cycling that battery, which we all know is not good for a non-deep cycle battery. So if we deep cycle the battery, even some manufacturers say one time, that's enough to require replacement. Others want it to be tested to figure out is it good or bad or not. Because the last thing we want to do is send a customer out and potentially have an issue with a bad 12-volt battery or low-voltage battery later on.
Yeah, it's exactly right. And what we see is that many OEMs are specifying the same 12-volt battery in the EV as they do in legacy ICE vehicles. But because the battery is used in a completely different way, even though it's the same battery, it still needs to be tested according to its application, even if it's used in an ICE vehicle also,
Yeah, we see that a lot where it's multiple battery, same battery used across
Right.
different models, and yeah, each one's going to have its own draw and needs, and we just can't fall back on that CCA rating because that doesn't matter to us in EVs. We can't
It's
fall back on
inapplicable.
that.
Yeah, exactly. Yeah.
Now with this tool here, does it give us some data that we can show to somebody?
Yeah, sure. It's a good question, and back to the connected tools point. All of them are connected. We capture data from all of them, and we provide it to the users in a very, very easy to understand report. It can be captured into the repair record. It can be used to substantiate repair processes and claims and anything involved in that collision repair chain, right? So it's all well recorded. Yeah, yeah.
Nice. So does this kind of round out your
This is
tooling for EVs?
our new category of EV safety solutions at the moment. Stay tuned. Cool stuff coming still.
All right, I'll stay tuned.
But yes, but thank you. Yeah.
Nice. Well, I appreciate you being here and be able to showcase some of this stuff and what the cool things you guys are doing to help, make sure these cars are safe for technicians working on these vehicles. It's really important to make sure everyone is up on their training, up on their tooling, because ultimately, at the end of the day, we just want everyone to go home to their family, no one to get hurt, and this will help us to make sure that technicians aren't getting hurt in the line of work, and be able to diagnose problems and figure things out, and the first responder type of tools and things like that. You guys are bringing a lot to the table here, so we appreciate you being here, and thank you for your continued partnership.
Thanks, Joel. It's a pleasure. Our pleasure. Thank you.
All right, well, that's going to finish us out here at the SEMA Collision Repair and Refinish stage. Thank you guys for joining us, and stay tuned for some more content.